And now, a laboratory study about queuing theory with a mouse. Yes, that mouse. So, this section relies on a rather informative video by the channel Defunctland about the history of the Disney Fastpass system. The actual video contains a lot of discussion about the history of Walt Disney World and some notes about other Disney parks throughout the world and all kinds of stuff that I would say is kind of not relevant here. It's cool if you're into that. I learned a lot about Disney in general and like how the system works. I should also note that a lot of what I learned is completely useless because Disney has now retired the system that we're going to talk about today in favor of something else. But it actually is something worth talking about. There's some stuff that we could learn from what we're going to discuss today. And what we're talking about are the Disney FastPass and FastPass Plus systems. They are not quite the same thing. There are a couple of differences that are going to be noted in this, and I've linked the full video here in the slides as well as the notes, so that you can take a look at it if you are interested. It does have a lot of Disney history, as I say, but we're going to try really hard not to get distracted. So there is in the video a simulation, and the simulation is based around the idea of a hypothetical park in which guests come and visit. I'm presuming in this situation that you're at least a little bit familiar with the idea of like Walt Disney World or equivalent sort of theme park. But simulation is required because of the complexity here, right? Our ability to reason about it and do the math around some of the queuing theory and stuff just vastly exceeds what we could do with by hand calculation or with a spreadsheet or Wolfram Alpha or anything like that. A simulation is going to be very helpful in terms of validating any theories or highlighting any important observations or conclusions that our system generates, if you will. But you might be asking, how hard, how complicated could it be? Well, let me try to explain some of the reasons why this is just as complicated as to require such a thing. And we're going to abstract away in the discussion a lot of the details about the mouse and his friends, but we're still left with a system that has many things that we need to consider. Number one is about customers. These are people who visit the park. They are requesters. They are there to have a good time. So you could say, they want the service that Mouseland provides, and that is interesting. They are independent agents, which is to say, their behavior is based on their own preferences, their own choices. They're not exactly the same. They don't behave as a crowd or a group or a herd or anything. Everybody is an individual, and they all do their own thing. And doing their own thing means one of a few things. Number one, they have different times of arrival and departure from the park. The park in this case represents our service center, our attraction that people are here to see. Most arrive early in the day, not necessarily right at opening, but they come in the morning, and relatively few arrive for the evening, so most people are there the majority of the day, and it really depends on their individual preferences and maybe how much of a morning person they are and who they're traveling with to try to figure out are they going to get there early or not. Number two, people have different preferences of what they want to do while they're there. So while you're there, you might want to go on the rides. You might not be interested in the rides at all. If you are interested in the rides, you probably have a preference order for which are the ones that you would like to experience versus which ones are, they're just fine, it doesn't really matter. It's completely different for every person. Some people are not interested in something that you are completely interested in. It does make it a little hard to go as a group, but that's okay. It's a good problem to have, right? Number three, everybody has a different willingness to wait for the things that they want to do, and that willingness can be different for each different thing that they want to do. If you want to do 3 different rides, you might have a priority ranking on them, and you'd be willing to wait the longest for the one that's the most important and willing to wait the least for the one that's less important, but that's okay. right? Everybody has a different willingness to wait. Another thing that we can think about is whether someone is willing to come back another day or not. And this also varies pretty wildly from person to person. If you live in the area, you can easily have an annual pass and you can come back any day. So if it's busy today, if it's not going well for whatever reason, you can just say, I'll come back another time. It's fine. But there are other people who have saved up for this once in a lifetime trip. It maybe involved sacrifices to be able to afford it. And this is their only shot. They're here today and they're not going to come back tomorrow. They couldn't even if they really wanted to. So willingness to come back another day is also highly variable. And then we have the park itself. And the park has opening and closing times, which implies a few things. Number one, requests cannot be submitted before opening time. You can't line up for something before the place opens because you're not allowed in the area. So that doesn't work. Number two, requests can't be submitted after closing time. I mean, when we close, we're closed. So they eventually send everybody home, even if they would like to stay longer. And requests submitted too close to closing time might not be served before closing. At some point, they're going to say, yeah, the park closes in a few minutes. We're sending you home. You can't just stay as long as you want, because that's a little bit impractical. Okay, so the park actually is a little bit easier to explain than, say, the behavior of individual guests, right? Guests are pretty wacky. At least the park, has rules. And the other thing that we should note is the park has different services that each have their own service rates. These are the different attractions. These are the things that people are here to see. Each of which has their own service rate, their own queue. And hypothetically, any of them could be down at any time, and downtime for one does not imply downtime for any others. So we can't easily relate them in that way. And the other thing that we should note is that services have a fixed maximum capacity. You can't make more seats on the ride, nor can you run them faster to get through more people quickly. Okay, that last one, interesting, right? Usually when we talk about software services, there is some capability of we can scale this up, we can offer more of whatever people are trying to consume, and it's a little bit hard to make this work with the situation that we are examining, right? Like, is this relevant? So I'm going to ask that question, right? Is this model actually relevant? When I talk about Service Ontario, right, ideally, the scenario is I arrive, I get service after some amount of waiting, I get service, I leave, and hopefully I don't have to come back again for quite a long time. Reality is often inconvenient, so I may have to come back before too long, but ideally I don't have to come back anytime soon. At a food hall, eventually I will get full. I will have reached my maximum capability of eating, and at that point, even if I really want to, there's kind of a limit that I just can't get past. I can't eat anymore beyond that point. Not a problem for Homer Simpson, as depicted in this classic episode, but definitely a problem for a mere mortal like me. But that's not how it works at an amusement park or a theme park. I go there, and my goal is probably to do as much as I can during that day, right? It's very different, right? I don't spend the whole day at Service Ontario in the hopes that by the end I will have accomplished everything it's possible to do at Service Ontario. Quite the opposite. I'm there to do one thing. So, is anything that we're going to talk about in this model really applicable to software services? I mean, what do you think about it? You should take a minute to consider. So I'm going to argue yes. You can disagree with me, and it would be kind of interesting to hear your arguments around the idea. But I'm going to argue the answer here is yes, that it is actually a somewhat relevant model. The first thing that I will suggest is that if I'm waiting in line for a specific ride, I'm here to see ride A, fill in your favorite in place of the name ride A, and there's 400 people ahead of me in line, it doesn't actually matter whether they've just arrived at the park and they're here to ride exactly one ride and they're planning to leave, or if they've been here for hours and this is their 10th ride of the day. That doesn't really matter. All that's important from my point of view while I'm standing in line is how many people are ahead of me and how quickly those people are getting to go ride on the ride. Rides don't have to be completed in a specific order, so you could say this is sort of stateless in this regard. When I say they don't have to be completed in a specific order, I mean like nothing bad happens if someone rides them, out of some order. There might be some order in terms of preferences, and you should do them in that order. There might be some order in terms of like this is the most efficient way to do it, but nothing bad happens if you do it in quotation marks wrong. Because what is right is mostly a matter of opinion, matter of perspective, if you will. You could also say that this model, even where somebody spends the whole day at the mouse park, going from ride to ride and from attraction to attraction, is fundamentally no different than one in which each person who goes on a ride immediately leaves the park, never to return, and is instantly replaced by another guest who has the exact same preferences about what to do, just isn't interested in the things that person who left has just done. So something like that, I'm going to argue, don't call this a formal proof or anything, but I'm going to argue that this is a reasonable way of looking at it that says actually we could map what we are seeing here to a typical software system in which people come get some service, they may need another, and then they're on their way. With more and more complex priority systems, my way of arguing about it might not hold up. You might be able to find some holes in the logic at some level, but hopefully, at least for the moment, this argument is somewhat convincing. So let me tell you a little bit about the simulation and the user types and that kind of thing. I don't want to get bogged down in the details of it, but the simulation has a few different archetypes. These are like broad categories of users that represent their, in quotation marks, personalities. It's based on the type of person who is likely to attend the park. Some of them are the people who come frequently because they have an annual pass and it's a nice thing to do on a weekend because they live nearby. Some of them are the people who are here today and today only, and they really don't want to miss out. Whatever archetype they fulfill, we represent them hopefully well in the model. Without telling you about all of them, and there are a bunch, and they're somewhat interesting if you watch the video, but what they determine is, number one, how long they stay at the park. So they arrive at a certain time, and how many hours are they willing to stay here, versus at what point are they going to say, okay, I'm tired and I've had enough. Number two, when they balk, what is their willingness to wait for a particular thing that they would like to see? And again, everybody's is individual in that circumstance. And number three, what they would like to do. What do they want to do while they're here? And that covers their preferences for rides and what rides they want to go in terms of what priority sequence. But it also says, do they want to do other things in the park? Do they want to go to the Harry Potter land and have a butter beer? That's not a ride, but it is nevertheless something to do. And so we have different user types that represent this sort of behavior. And there are three systems under consideration in the simulation. And the baseline is there's no priority system. Everyone is equal. And that sounds kind of nice. It does sound like it has a certain level of fairness to it, but it may or may not represent the best outcome. Obviously, the simulation will have to demonstrate that. And then there's the two kinds of priority systems, which the mouse refers to as Fastpass and Fastpass Plus. I am sure the developers wanted to call Fastpass Plus Fastpass Plus Plus, but I presume they were overruled by corporate types who just didn't understand the joke. Okay. Let's imagine each of these just in brief then. In the no priority system, as I said, everyone is equal. Wait times are just based on how popular things are, and nobody gets to cut in line. One potential advantage of this is that wait times are predictable because, well, whatever queue a person is waiting in, it advances at a fairly steady rate. And although this has a certain level of fairness in terms of like social fairness, we're not sure yet whether it is optimal. We'll have to see. And then there is the Fastpass system. And in the Fastpass system, instead of when you wait in line, you can get a little ticket that specifies a return time. And when you return, you go to the front of the line if you possess this little ticket. This allows people to do something useful or fun in the meantime, and maybe profitable for the mouse if you buy some food or something to that effect. And that makes it a virtual queue system, as far as we're concerned, and it's not really a priority lane. You're waiting in the queue just as long as you would otherwise, but you're not just having to stand in the physical one, doing nothing while you wait or staring at your phone or something like that. This does potentially allow you to get some other stuff done. As you can imagine, in like a food hall scenario, you can get some gelato while you wait your turn for pizza. In the mouse park, the Fastpass system is applied to only the few most popular things. So for all other attractions, there exists no fast lane. In the Fastpass Plus system, in advance of going to the park or on arrival, you get 3 priority passes to some specific attractions well in advance, and these passes can sell out. This resembles making reservations more so than waiting in a virtual queue. And as you can imagine, people try really hard to get the priority passes for the things that are the most popular. Regardless of whether it's the Fastpass or the Fastpass Plus system, there's 2 queues for any individual service, as illustrated here by there's a Fastpass entrance sign. And the priority queue, or the fast lane, and the standby queue, which is the one for everybody else. If a ride can seat some N people at a time, the ratio of priority to standby is important. Under typical circumstances, the ratio of priority to standby is something like 4 priority guests to every 1 standby guest, but in times of big backlog of the express line, it could get up to 20 to 1 or even 100 to 1. And as you can imagine, the 100 to 1 is extremely frustrating for the people who are not in the express line. Okay, so given all of this setup, I think we have enough of an understanding to try to interpret some of the results here. So let's recap the results and the results in the video, obviously. But one of the things that's nice about this is you could play around with the simulation yourself if you're so inclined. I've linked here the GitHub repo that contains it. It is Python, yes, but it's not super complex. The logic and the details of it don't require deep Python knowledge to actually do the simulation and to play around with it. So if it is something that you were interested in trying out and sort of seeing how it goes, or doing your own experiment, you should be able to do that even if you don't really know any Python. Okay, so let's break down results into 3 categories. And they are, number 1, standby waits, number 2, overall waits, and number 3, average number of rides experienced. So let's look through those results. So standby waits do increase using the Fastpass system, but that's not super surprising. If some people can cut in line, that obviously helps them, but it delays everybody else. The Fastpass Plus approach increases the wait times on every ride except the most popular one, and even then it's just like a small amount decrease. But it often increases waits by a significant amount in the other places. On the screen we can see there's like different shapes. The polygons represent different rides. They're just given sort of polygon names to abstract what they are in the simulation because it doesn't really matter. And each of these is showing, on the leftmost column, no Fastpass, in the middle, the original Fastpass, and then Fastpass Plus as the column to the right. Okay, we know that whatever priority system we use, it makes things worse for the standby system, but that's expected, but not everybody is on the standby system. Some people are in the priority lane, and they have a much smoother path to getting to where they want to go, right? So, okay, does the Fastpass system change the overall weights? And here we have just a comparison of the average overall weights with no Fastpass paper and Fastpass Plus. Okay, so that's kind of interesting, right? With no priority system, if a guest tries to do everything all at once, in everything once during the day, then they would, on average, be waiting about 41 minutes. But in reality, that's not what actually happens, because, well, it turns out people want to do the most popular things, so your wait is 58 minutes on average in reality. And that's what the two different columns sort of represent there. If you tried to do everything one time, you would have about 41 minutes of waiting. If you tried to just focus on the most popular things, you would have more. And if we consider the behavior of everybody in aggregate, yeah, more people want to do the more popular things, so the waiting for those is longer. With the paper Fastpass system, we can actually see that the average wait in standby, if doing every ride, is 48 minutes, but the actual wait time is more like 40, which is about 2/3 of the wait time of the no priority system. That sounds pretty good. It sounds like it works, doesn't it? But keep in mind, part of the benefit here is from basically encouraging people to go to less popular things because they have a shorter or no wait, and you can do that while you're waiting for the popular thing for which you're holding the paper ticket. The Fastpass Plus solution raises the average standby wait for doing everything to about 67 minutes, but the typical wait per attraction is 42 minutes. Again, this is because the wait times are longer on standby, but average times are reduced because people are encouraged to go to less popular things and make use of those. So at this point, you've probably figured out that one of the real goals of the priority systems is to incentivize people to go to the underutilized attractions. And the average number of rides will, of course, vary depending on what system we're doing. Without any priority system, it's 3.31. With Fastpass, it's 3.77. And with Fastpass Plus, it's 4.23. Okay, that sounds good. But the actual distribution here is fairly uneven. It increases the number of people who go on a lot of rides, but it also increases the number of people who go on very few. And you can see the people here at 0 and 1 and 2 actually represents a fair number of people. So that's kind of weird. Is that desirable? Maybe, maybe not. I mean, there are people who came and they didn't want to go to any rides anyway. They hate roller coasters, or they hate rides, or they just don't want to stand in line. So they didn't want to do any of them anyway. And there's people who came, for their one thing. That's what they're here for, and they're happy to leave once that's done. That's a possibility. But it is more likely, when we look at this, that it's people spend a lot of time waiting in line, and they're not getting the things that they want to do done today. So that isn't the ideal. The distribution, produces an obvious indication there are winners and losers in the system, whereas the original Fastpass system doesn't seem to do that. So that's kind of interesting. So yeah, lessons and limitations. So what can we sort of learn from this? Priority passes don't realistically affect the wait times for the most popular things. Those don't change by a very meaningful amount if we introduce them, but it does encourage more usage of less popular things. Is that an improvement? I see the mouse is thinking about it. I mean, what argument would you make? Is it improvement or not? Well, the mouse on the screen here is in the business of entertainment. The mega corporation wants you to spend money with them, consume, obey, and most likely a guest will return and spend more money if they've enjoyed their visits. Is going on more rides better than spending more time in queues? Maybe. I mean, at least I think so. But of course, that's just like my opinion, man. It probably makes some intuitive sense, right? That like at one extreme end of the spectrum where I never have to wait at all, I'm a prince of Disneyland, and I can always go to the front of the line and never have to wait for anything if I don't want to, I'm probably extremely happy because I get to do everything I want to do with no waiting. At the other end of the spectrum, where I wait in line all day and never actually go on any of the rides I want to go on, probably I'm extremely unhappy in that situation. And so, although you could probably argue that there is not a linear amount here, at some point I will get sick of it, or I will just get motion sickness, or I will lose interest. We can probably imagine there is at least a linear range of this where getting to do more things is good. However, I'm pretty unhappy if I don't get to do my favorite things, even if other things are available. It seems like overall, getting to do more rides is good in terms of increasing guest happiness. If most guests follow a similar evaluation process of like, yeah, I got to do more things, I got to experience more things, being preferable to more waiting and not experiencing as many things. With that said, the simulation doesn't account for, say, downtime during the day. There might be some maintenance baked into the estimates of capacity, but I mean the kind of downtime where a particular ride goes offline. And if it doesn't come back that day, that's kind of interesting. In a simple model of a scenario, you could say, if the ride goes down, with some low probability, then we just send everybody who's in the queue back out into the into the world and say, well, decide now what you want to do. Maybe they go to the next attraction. Maybe they just give up and go home. That's a personal decision. But in reality, people who had some sort of fast pass for the ride that went down might get another fast pass as compensation, which could have interesting downstream effects. Similarly, if you waited a long time, even in the standby line, and you ended up with nothing to show for it because, again, the ride went offline, then the Mouse employees might try to give you a compensation of some sort, and if that compensation is another fast pass for a different attraction, that could actually kind of mess up the whole thing because we've now increased the number of passes in circulation, and maybe that adds some chaos. So that might be actually kind of a fun extension of the simulation of like what happens if we do that. The other thing that is very noteworthy by talking about this is that the knowledge factor represents a huge amount of the inequality that we see in rides per day and what have you in real life that even goes beyond the simulation. People have learned the nuances of the system, and there's innumerable websites and videos and things telling you about here's the secrets and here's how you maximize your day at the park that you're planning to attend. And I mean, some of these things are things I would never have thought of, honestly. But there's like whole websites dedicated to the idea. And people who learn the nuance, get to do more things. If you've mastered the system, you probably get to do a lot more of the things that you want to do, maybe ride 8 or 9 different rides, as opposed to somebody who's completely unaware of the system, who might only get sort of 1 or 2 rides in. And there's a lot of videos out there about how you can maximize your experience. With that said, I think I mentioned already that Disney has decided to get rid of this, and as far as I could tell, the new system is just like much more crass, like, would you like to spend money to go to the front of the line? Which I guess has the advantage of being simple, but boy, they're just not even shameless about it anymore, are they? They're just one step beyond shameless at this point. With that said, the simpler system, interestingly, at least is understandable, and you know what to do and you know how to deal with it. A final lesson I think that we could take away from doing the simulations and all of this, and looking at what is the impact of Fastpass and Fastpass Plus, is that the more complex your system, the more likely it is that somebody who's truly knowledgeable about it will be able to exploit it in some way. And it's very likely that they won't keep that to themselves, right? People will tell their friends, or people will tell their family, or they will write a blog post or publish a YouTube video explaining how to maximize your time at the amusement park, and then the secret is out. And the more complex the system, the more opportunity there is for users to behave in unexpected ways, and do things that you didn't necessarily expect. And that might actually mess up your capacity planning, or it just might make the user experience for everybody worse. So yeah, when it comes to trying to have a good time at the House of Mouse, it turns out that knowing is more than half the battle, and so now you know.